Hey, everybody, and welcome to Slooh, your interface to outer space. I'm your host for this show, Eric Edelman, and today we have our eyes on the sun because NASA has announced a brand new mission to, of all things, touch the sun. So this mission was announced yesterday, and today we'll be looking at just what this mission is and what we expect to learn from it. And all the while, we'll be looking live at the sun through our special solar telescope in the Canary Islands and from our feed from our friend Matt Francis at the Prescott Observatory in Arizona. So here what we're seeing is a live view of the sun from the Canary Islands. So yes, you don't have to look directly at the sun today to see it and damage your eyes. We're giving it to you without having all that danger right in front of your face. It's a beautiful, beautiful, gorgeous view of the sun in H alpha. And so we're going to be seeing how this sun progresses live through our broadcast, seeing what our experts we're going to have on live will be telling us about what this sun looks like and what we can expect from this really exciting new mission. It's going to be a Parker Solar Probe is what they're going to call it, which is going to be launching toward the sun in 2018 in the summer, in either July or August. And this probe is going to get very, very close to this bright, bright star. It's going to get about 4 million miles away from the sun at its closest. And so to give you an idea of just how close this is, keep in mind that Mercury, the closest planet to the sun, is on average about 36 million miles away. So this probe is going to get 9 times closer, thereabouts, to the sun, also going to be about 8 times closer than the previous closest man-made craft, the Helios B spacecraft that was sent over in the 70s. So it's going to get very, very close on its mission to touch the sun. So what does that really mean? Well, just like our Earth has different layers, the crust, mantle, core, and different parts of the atmosphere, so does our sun have different layers as well. What we tend to see when we look up at at the sky, hopefully with the right eye protection, be very careful with your eyes when looking at the sun, of course, is the photosphere, this really bright layer of the sun. Yet it's so bright it sort of obscures the rest of the view. But when that layer is blocked when it's a bit dimmer. Say during a total solar eclipse, we get to see other fun layers as well, including the wondrous solar corona, this distended aura of plasma, this hot ionized gas that extends out millions of miles into space, which is what this spacecraft, this probe, is hopefully going to be touching and telling us a little bit about how that gas works and also how it might relate to the solar wind and how that might, relate to our experience here on this planet Earth. So there's a whole lot of stuff going on with this mission and a whole lot of exciting things that our experts on the show today can tell us all about this. And so joining us to help us understand what is going on these live images and also in the minds of the scientists that are heading this Touch the Sun mission are a couple of great guests. First up, we'll be speaking with astronomy journalist and author Bob Berman, who will help us get to know our sun as we understand it now. So baseline, what's our knowledge here? Bob is an expert on the sun and how it works, and we'll talk about how we've managed to learn what we have, how we've gotten to where we are without touching the sun in the first place. And we'll also be talking to a brand new member of our Slooh team. Very exciting. Yes, drum roll for that. Dr. Paige Godfrey joins us for the very first time and hopefully the first of many. Paige is our new head of research here at Slooh and will be giving us the inside scoop on the mission and also on the NASA perspective, what NASA hopes to learn from going all this way out into space. So that's all coming up in just a few minutes, so stay tuned. We'll be right back.
We've been all over the world chasing solar eclipses to share with you. This time, you're coming with us. Join Slooh as we expedition to Stanley, Idaho to celebrate the transcontinental eclipse on August 21st. Sign up today at slooh.com. Space is limited.
Hey there, everybody, and welcome back to Slooh. I'm your host, Eric Edelman, and we're looking live at the sun through our telescope in the Canary Islands right now. There it is. There is our beautiful view. And now, right now, it's a little bit late in the afternoon in the Canary Islands, so our equipment has gotten a bit hotter. It's exercised itself a lot throughout today. So what we're seeing is, even though it's a gorgeous view, it's not necessarily the optimal view that we can see through these scopes. I believe we have a gorgeous image of the sun at peak beauty through our Canary Islands telescopes that we can also show you at some point during the show. And also in comparison with what we see in the Canary Islands, we can also have a gorgeous feed that we have as well from Prescott Observatory and our wonderful feed partner, Matt Francis. That's another feed that we can bring up as well. This is the Canary Islands, another gorgeous view. This is not the live view, but it's something that we have taken with this telescope before, and you can see a gorgeous pair of sunspots and also some wonderful activity just going on all across the sun. So this is a really great image that we can get into a little bit with our experts as well. That's going to be exciting. So we're hoping to learn a lot of things about the sun. Oh, and also here we have the Prescott Observatory feed coming to us live from Prescott, Arizona as well. Yes, a lot of activity going on this sun. This is just a wonderful time to see it. You don't always know what you're going to get when you have a solar show, but there is a lot of stuff that we can bite into. So this is going to be pretty cool. So yes, a lot of stuff to talk about on the sun itself right now, as well as our plans for this sun in the future. And so what we're going to talk about right now, though, is where we're starting from. What is our baseline knowledge at this point? And to help us understand more about what we've already learned and why we're studying the sun and why it's so important is none other than astronomy journalist and author Bob Berman. Now, Bob, thanks so much for joining us here today on this sunny show.
Great to be here, Eric. Thank you.
So, I mean, just to start us off, I think we have a lovely view of the sun here from Prescott Observatory and our wondrous feed partner, Matt Francis. I'm wondering, could you tell us a little bit about some of these more exciting points on the sun? Like what's going on right here in the feed?
Yes, well, we're seeing granulation on the sun, sunspots, storms on the sun. Those one is just rotating into view. The sun takes about a month to spin, interestingly, the same rate as the moon. And one of the features is just coming into view. If they ever get to be at the very center of the sun, from that point on to 2 or 3 days rotation after that, then it's in a position to throw the material at Earth, causing all sorts of disruptions in communications and beautiful displays of auroras and all the rest. So we watch this stuff as it rotates into view, and some of our spacecraft, like STO and Stereo and some of the others, we've got an armada of spacecraft watching the sun right now, so that as it rotates into view, we even know it's coming before it gets there into sight. So it's a lot of fun. And yeah, Prescott, you're saying Prescott, I say Prescott. I've been out there a few times, and when you're there, you learn that the people who live there in that part of Arizona say Prescott. So you can always tell the outsiders like you and me who say Prescott, and the people who live there say Prescott. It almost rhymes with biscuit. This has no relevance to our show, but just thought I'd mention that. Yeah, sun is
The
very
more you
exciting.
know. Yeah, the more you know. And well, I think you've answered this a bit, but I mean, in terms of the sun is far away from us, but it also, I think, has some ways that, while we're trying to touch it, it can also touch us. I'm wondering, why exactly do we study the sun, Bob? What are the big deals that cause us to really need to know about this object?
Well, Eric, because our lives obviously revolve around it, we've found that the sun doesn't just mind its business, its own business. It sends us things. It's not just all the nice heat and light. Sun puts out from its surface that photosphere, which, by the way, is such a thin surface. That is what we're seeing, the visible part of it. It's only a few hundred miles thick. It's like painted on. And a lot of people think, well, that's where the sun's radiating all of its light and heat. It's radiating it, but it's not producing it there. All the energy, and this is another reason we're studying it, comes from a little tiny ball, only about a quarter the size of the sun. So picture a little sun within the sun, a little 1/4 of the size ball in the exact center, which is where all those nuclear fusion reactions are going off at the rate of 96 billion 1 megaton H bombs per second. That's the rate of solar generation. We could say 4 trillion watts of power. Okay, that's true too, but 96 billion 1 megaton hydrogen bombs per second coming from that ball in the center. You see on that picture we have up now on the left side that it's shown in blue as a little small core in blue. So that's where it's created, mostly in gamma rays, which you have a degree in astrophysics. Gamma rays wouldn't be fun for us at all. Fortunately, as these very high energy short waves of light squirm their way out and get to the edge, some say in as much as a million years, some say less than that, it's absorbed and re-radiated by all the atoms it has to encounter, so that by the time the stuff comes out, it's a 50-50 mix of infrared, which we sense as heat, and light. But Gene Parker, for whom that spacecraft, the Parker Solar Telescope, which will be launched next summer, is named, Gene Parker in the 50s said something else comes out, and that is a wind, a stream of fast, broken bits of atoms, typically flying at 200, 300, 400 miles per second. And that's why comets have their tails pointed away from the sun, like windsocks. And that's why we see these. He predicted this before we had satellites that ever detected the solar wind. And in the great tradition of science, he was ridiculed. People back then in the 50s said, yeah, right, a solar wind. Yeah, sure. And he was really ridiculed. But he turned out to be right. So it's nice that now the spacecraft is named after him.
Some bit of vindication for him. And so, as we're sort of exploring all this stuff a bit more, particularly far away from us, really close by, like what our lives sort of do revolve around the sun, and how does that sun like directly impact us besides giving us light? What is that solar activity, if it reaches our planet? What sort of effect does it have on us here?
Well, first of all, it varies, as you know, in the 11-year sunspot cycle. That is not that much of a difference in brightness. The sun gets a little brighter, a little dimmer in roughly an 11-year period. Instead of an average of 1,365 watts per square meter of Earth's surface, it goes up or down by a watt or two. That's not the big deal. The big deal is in ultraviolet, especially in the far ultraviolet. The energy it sends us, even though ultraviolet's only a few percent of the sunlight, it has a powerful effect, and this can vary by quite a bit. We're talking about 20, 30, 50% varies with the sunspot cycle. This affects, apparently, cloud formation, ocean temperatures, and all sorts of things. So aspects of Earth that we never knew about are being influenced by the sun's activity, the sunspot cycle, and you bet we want to learn more about it.
Oh, absolutely. And I feel like, as somebody who even wrote a book on the sun's heartbeat, I feel like you must know a lot of really just things that we don't normally talk about. Like, I was wondering if you could tell our viewers at home what maybe is the most sort of intriguing off the wall fact that you know about that sun hanging up there in our sky?
Well, it starts off with the strange fact that it's the size it is, that we only have two disks in our sky, the sun and the moon. Everything else, of course, are dots. Even planets look like dots without a telescope. And we only have these two circles, these two disks, and they both appear exactly the same size. That the sun is 400 times the diameter of the moon, but 400 times more distant. Or to put it another way, about 108 suns distance from us. See that ball we're looking at live right now? Well, about 100, a little over 100 of those separates, stacked side by side, separates us from the sun. With the moon, it's a whole other story, but they appear the same. And that's why this August 21st, as Slooh will bring us, we're going to see the moon just barely being able to fit over the sun to produce the spectacle of the total solar eclipse. No other planet has that, where their moon or one of their moons can just perfectly cover the sun. And that's one of the great coincidences of nature. And it's a simple fact, perhaps it requires no astrophysics to appreciate, but it has all these consequences, as everyone is going to see this summer.
Yeah, not only is our sun beautiful, but we have this uniquely beautiful perspective of the sun, of these amazing eclipses that can be created because of that incredible ratio. It's a lovely fact. I love thinking about it. And Bob, thanks so much for talking about the sun and what we can expect, what we've learned. Thank you so much for joining us here today.
Oh, my pleasure, Eric. Thank you.
Absolutely. Now, coming up, well, we know where we've come from. Now, where are we going? Where do we go from here? And of course, we're literally going to the sun, and we'll be sitting down with our newest Slooh team member, Dr. Paige Godfrey, to find out what the mission scientists are hoping to learn by touching the sun. So stick around for that. We'll be right back.
Give the gift of the universe. Give the gift of Slooh, a celebration of every magical moment in the night sky. For just $60, you can give the budding space explorer in your life the gift of a full year of Slooh membership. It's available now at slooh.com.
Hey there, everybody, and welcome back to the show. Whether you're watching from Slooh.com or from Rockets Are Cool from the Weather Channel, I'm Eric Edelman, your host for today's show, where we're trying to figure out what NASA is going to accomplish as it tries to touch the sun. So right now what we're doing is we're looking live at the sun from our solar telescope feed from our wonderful partner Matt Francis at the Prescott Observatory in Arizona. So we just have a gorgeous view of the sun where a lot is going on. I love looking at those just those sunspots. They're just crawling their way across the sun right now. And joining us right now to explain more about why we're sending a mission towards this bright, glowing orb in our sky is our newest Slooh team member, Dr. Paige Godfrey, who is the new head of Slooh Research and will be leading the charge with all our professional amateur research and discovery collaboration. So facilitating that sort of great teamwork that we love to see here around Slooh. Now, Paige, welcome to the show and to the team.
Thank you. Thank you for having me.
Yeah, it's going to be great, I think, having you on all these shows. And before we jump into talking about this Touching the Sun mission in particular, I was hoping you could tell us just a little bit about yourself and what you'll be doing here with the Slooh community.
Absolutely. I'm very happy to be here. I graduated from the City University of New York with my PhD just this year, and I'm super excited to join the Slooh team. Our mission for the new research department, it's brand new, and our mission is to combine research from the professional level with the amateur level. So one of the things in astronomy that divides the world and the public is the professional astronomers. We have all these conferences, and then you find out the information through the media. But what if you want to participate in it? We have these wonderful amateur astronomers. They're looking up at the sky, they've got backyard telescopes, they're doing research right at home. And being able to combine these two and publish papers together, like these citizen science projects you see, like Backyard Worlds and things like that, we're bringing that to Slooh, and we're going to be able to connect the two communities. It's going to be really cool.
Oh, that sounds really great in terms of just harnessing everyone's passion, getting more done. This should be really great. I'm excited to see what comes out of all of this. And so we have exciting missions here at Slooh, and also NASA's doing some as well. And now NASA's mission, Touching the Sun. Why do we have to go all the way to the sun to get this mission done? What's so important about touching the sun in particular this time?
Getting as close as we can is always the goal. For starters, it's the closest star, obviously, to us. And so why not? We can now. We haven't been able to go before because the sun is really hot. And we have updated technology now that can protect the satellite so that it can get there. So with this new heat shield, we'll be able to actually get very close to the sun. And from being in the layers of the sun, in the corona, the mission is going to be able to see the energetic particles that are being created right at creation. We're going to see the particles being pushed out of the sun, the solar wind. The satellite will be right in this.
So we're getting right into the middle of the battle zone, I suppose. And what is the main sort of goal that we're hoping to get from this mission? What are we hoping to learn? What's going to be some of the most valuable knowledge that we'll hopefully gain from this?
There's two big questions that NASA's trying to answer with this mission. The first one is, interestingly, the sun has a bunch of different layers, and the surface, what we call the surface, is the photosphere of the sun. That's what we can visibly see. And that is about 6,000 degrees Fahrenheit. You would think, I mean, the core is the hottest, and then the photosphere is, like I said, about 6,000 degrees Fahrenheit. And you would think anything outside of that should be even cooler. All this energy is radiating away. But interestingly, this corona, the outermost layer of the sun, its atmosphere, is warmer than the photosphere. And physics says, well, it shouldn't be. So there's been some theories proposing why the corona might be hotter, but this probe is going to be able to go prove those theories, hopefully. So that's the first biggest mission, is to understand why the corona is hotter than the surface. The second part of it, the second goal, is solar wind. So you might have heard, from Earth that sometimes the solar wind, if it's super strong, can cause power outages on Earth. It definitely affects satellites that we have in our orbit. It affects missions, astronauts trying to leave the Earth. And so we want to try to understand the solar wind better, especially from again, like I said, being right in its creation, as soon as it leaves the sun, we'll be able to understand the physics that goes on in the solar wind and better predict how it's going to affect Earth and technology we have orbiting Earth.
So even though it's a mission that goes far away, it also sort of resonates close to home in a
Yeah.
way, which I think is a nice bit of symmetry there. And so it seems like there's a lot of exciting things that can come out of this mission. And but also, beyond the mission, sort of talking about sort of your new arrival here at Slooh. With these new recruits, we love to ask all of you sort of some initial questions first when you're joining us here. And one of those big ones is, why were you inspired to walk the path of astronomy? What got you into this astrophysical world?
Oh, that's always the question, right? Well, uh, I guess like a typical answer sometimes, for some people, it started when I was a kid. My parents said I was notorious for asking why. Why does this work? Why does that work? My dad told me one time he had to spend about an hour showing me how the back of a toilet worked because I needed to know the physics of it. And so just going through life, I always had this curiosity. It developed into science, it developed into physics in high school. And then in college, you kept having to get more narrow. Your advisors would say, "What are you going to study next?" And I was like, space. I just always thought that was the biggest why that I could try to answer is, why are we here? What are we looking at? It fascinated me. And it was the biggest kind of why I could get my hands on. So I kept going, went through graduate school, and here I am.
They say curiosity kills the cat, but I think it also makes the scientist. So there's two
Right.
sides to that coin. And so you said you had to get into narrower and narrower fields of specialty. And I was wondering, out of all of the gigantic universe, all of all the subjects that are out there for you to study and explore, what do you think about space is the most fascinating or inspiring for you in particular?
Oh, wow. Ah, there's so many things. I I study brown dwarfs, so they're substellar objects. They're a bridge between the lowest mass stars and the highest mass gaseous planets like Jupiter. So, you hear about stars and planets all the time, and we're trying to understand how they form and how they evolve. But there's these objects in between that can show us just how we push the limits of what constitutes a star and how the processes of star formation go. And also, these objects, interestingly, look like Jupiter. And so sometimes they can behave like planets. And so, because, I mean, Jupiter is super close to us, but many other Jupiters out there, they're so dim and they're hard for us to see, especially when they're orbiting a star and the star is so bright, it outshines the little planet. So, these brown dwarfs, because they're bigger than Jupiter, they're brighter and they can give us insights into what these gaseous planets might look like when they orbit other stars and things. So that's the field I got into. And I think it's super interesting. Exoplanet science is, a frontier of astronomy right now. And so being able to study brighter objects that look like them is really cool. I also have a secret little passion for parallel universes and dark matter and all of that fun quantum level stuff, but not what I study.
It's stuff that gives you a bit of an existential crisis. If you need a dose of caffeine, need to stay awake at night, yeah, think about your place in the universe.
Hmm.
It's wonderful. And so, as somebody who has studied sort of stellar-like objects, specializes in maybe stuff a little bit smaller than our sun, I was wondering maybe you could give us your thoughts on this live view of the sun right here that we have from Prescott Observatory. Our feed partner Matt Francis, like what about this live feed? Really stands out to you? What do you think is interesting about what we're seeing right now?
So, what's interesting to me in my field of study is actually the solar wind and the radiation that comes off the sun. So, you can see in this live view sunspots, those dark points on the sun. They're actually caused from a temperature gradient. So, the sun has an intense magnetic field, stars do, and they're rotating. And the magnetic field and all the heat sends these jets off into space, these plasma jets. And when they leave the surface and they fall somewhere else, they interrupt the convection that's going on and causes temperature gradient. So you can see the dark spots. And this is what causes some solar wind that comes our way. So, in terms of brown dwarf science and exoplanet science, and basically bodies that orbit stars, they're highly affected by the solar wind. If you're really close to the star, you're going to have a lot more radiation. If you're far, you'll have less, which might make your planet too cold to live on. But the solar wind is really interesting to help us understand other solar systems that we can't get to with a probe because they're too far away, and being able to understand potential habitability around them based on the solar winds from their specific host star.
Seems like there'll be a lot of far-reaching consequences for this mission. It's going to be exciting to see what develops over these years. And so, as we are discussing this mission, what we can learn from scientists and amateur astronomers collaborating together, looking at these live views of the sun through the Slooh telescopes, what sort of drove you out of all the astronomy organizations in all the world? What brought you here to Slooh? What's exciting about this for you?
I am just so on board with the mission of Slooh. I spent 5 years in graduate school, and probably from about midway through my first year, I started thinking, what am I going to do after this? And the traditional route is academia. I love teaching, I love bringing that into the classroom. But I thought, what other things can I do? And I spent some time in graduate school doing outreach, public science writing, public talks. I really developed a love for outreach. And so I kept asking everybody, what career exists that combines research and outreach? I don't want to quit research, but I definitely want to do outreach. And I wasn't sure. And all of a sudden, in my senior year, I stumbled on Slooh, and it was just the absolute perfect fit. I'm so believe in the mission, and I just can't wait to be a part of it.
Yeah, well, Slooh, so happy to have you here. We're really excited, I
Thank
think,
you.
to see what you contribute to the team. And yeah, thank you so much for not only joining Slooh itself, but for joining the show here today. We appreciate it, Paige, and we also look forward to having you back many, many times.
Absolutely. I look forward to it too. Thank you.
Thank you. And well, that's going to actually wrap it up for us here today. We hope you enjoyed all of our guests and our live views of the sun. Thanks to our wonderful feed partner, Matt Francis, for helping us out. And our telescopes in the Canary Islands contributed like this live view here as well. And of course, a big thanks to our guests as they contributed through this afternoon, astronomy journalist and author Bob Berman, as well as our newest recruit, Dr. Paige Godfrey. Now, you can join in on keeping an eye on all things happening in space, from meteor showers and comets to the sun, the moon, the planets, really the whole universe, essentially, and by making a reservation on our telescopes in the Canary Islands and in Chile as well. We have a global telescope network here on Slooh, and any paying member can actually reserve time on all of our telescopes, looking live at stars and planets and galaxies and nebulae and all sorts of celestial objects and happenings, stretching your imagination and your knowledge of what exists out there in the universe. Now, next week, what we're going to be doing, we have shows all the time, and this time we'll be turning our eyes to the moon as it becomes the smallest moon of the year, the tiny, tiny, the mini strawberry moon, the cutest moon, will rise in the night sky on June 8th, and we'll find out just how the moon can change in size throughout the year. What's going on in the sky to cause it to be so mini? And of course, we are constantly pointing our telescopes at the most interesting things in the night sky and streaming them live in the Situation Room. So tune in nearly every day for a different object or view, accompanied by music and fascinating facts. Now, that's all coming up here on Slooh, so join the community, interact with other members, and just tune in. So yes, that's been our show. I'm Eric Edelman, and you've been watching Slooh. Now, have a great day, and thanks so much for stopping by.